Okay, so let's talk about part two. So in this one, just like kind of the end of the last one, when the questions get more kind of like explaining, I guess, you're gonna see me write a whole lot less down because like this is more me trying to have a conversation with you about what this means, and that doesn't necessarily mean I'm just gonna like say, hey, write these three things down and you're gonna get a good grade. Because again, you're gonna have to prove to me, excuse me, that you have a good sense of what's going on. But I can help you with through some parts of it. So take number four. When you talk about this progression from 0D to 1D, how do you do that using these terms I'm kind of mentioning here, like infinity, collinear, coplanar, and non-coplanar? We talk about quantities, orientations, and exclusions. A simpler way to think about this would be like, well, what if you're going to make like 1D? What do you need to identify? How many things do you need to identify to initially know where a thing is? And how many do you need to identify before you actually have the definition that you want? So let me try to explain. Let's talk about 0D to 1D. So we know that the 0D we know that the 0D are just points, okay? So we can start with that as a kind of a basic premise. So 1D, they're just points. So if you want to go from 0D, oh, that's not writing, 0D to 1D, the question is like how many points are you going to need to accomplish that? Well, initially you're going to need two, right? So you need to pick a point and you need to pick another point. That gives you an orientation. So two in terms of quantity. Now you have an orientation, and an orientation is collinear. Please recall that only any 2 points can be collinear, and so once you identify two, now you have a vision, excuse me, of where the line is going to actually live. Um, Now in terms of like finishing this out though, even though you initially need 2 points, well, certainly going to need a lot more to actually make this a fully defined line. And that's what I mean by kind of like shifting that quantity. So you needed two initially, but now you need an infinite amount of points before you can actually say you have a line. Now, in terms of exclusions, that means we need collinear points. So two to start out, then you need infinite collinear to make this an actual line. And so that's a very technical kind of explanation of how a line is formed. Like the functional one is like, yeah, you just pick a bunch of points that are kind of all lined up. So going back to our discussion, kind of like on the technical and functional difference, we are looking for a technical explanation here, not just a functional one. And so you can kind of view that in the same way now moving forward to like 1D to 2D. So if we're living in the 1D world that's full of lines and we're trying to head off into the 2D world, which is defining a plane, again, think what you need to start. Well, we have lines to work with, so let's talk about lines. So that's not enough to define a plane, but if we include a couple more lines, which of course you can view as kind of like seeing 3 points, then we have a vision of where the line now, or excuse me, the plane now lives. Now this of course doesn't mean I have the plane finished. What I'm going to have to involve is a whole bunch more lines until all the points on this plane on this flat surface are going to be defined. And so again, we can kind of turn to this quantity orientation exclusion thing. And so we do need 3 points or just two lines to actually start and know where our plane is. But then we're going to need an infinite amount of lines to define the whole thing. And these lines are going to have to be coplanar. Right? And so you should see a kind of pattern emerging here. So you need 2 points and then an infinite number of points to actually define a line. Then you need 3 points, which end up being, help us define three lines, and then an infinite amount of lines to define all the points you need. And so by no kind of secret here, if we're going from 2D to 3D, we're going to have to start with some planes and some points, and then we're going to have an infinite number of planes to actually finish that up. And so if we have like a plane initially here, and maybe switch colors to make this more clear, and we pick a new point, well, we have a plane there, and we have another one kind of like right here, back up there. There we have now a 3D definition. And so we have 4 points initially, which is really just three planes. And then, of course, we're going to need then an infinite number of planes in a non-coplanar way to finish defining the rest of that space. So number 5 is kind of a follow-up to this. Explain whether it's more correct to say in your previous answer that you were creating space or defining it. In your answer, also be sure to explain whether or not each of the spaces are tangible, as in whether or not you can touch them. Well, this is something you guys did a great job figuring out. This is not what you're doing at all. You're actually defining it. This means, of course, that the points are already in existence, which then implies that they're not actually tangible. So it's more like a transparency that we place on top of our world, that we can kind of interact and see things in a very technically theoretical way. But in the end, it's not something you're going to run into. So even though you have a line defined between any 2 points, you're not making those points. You're just picking locations of those points. And the line that you define collinearly with those 2 points is not something you're going to run into, like, cut yourself on. It's just something that exists in a theoretical space around our world. That's really kind of part and parcel to the idea of dimension. Most dimensions, although we know they kind of exist and we can define them really well, they're not tangible dimensions. Like a line is not a real thing. We can represent a line in our world, so we kind of know the properties, but in the end, that's not a real thing at all. And you guys have been doing an extremely impressive job explaining that type of phenomena, so you should be proud of that. Hey, I'm going to stop the video here. I'll see you guys in part 3.